Hello and welcome to the section where we are going to talk about writing equations of lines. Now, in all of our past things, we've had equations of lines such as y equals 3/4 x plus 3 or 2x minus 5y equals 4, something like that. We've had equations, and from these equations, we were able to grab out points. We would pick x equals 0 and stick it in and get a point. We would be able to stick in x equals 7 or 15 or pick any number to stick in for x or y and solve and get the other one. So we could get points out. We can extract slope. We can extract, here the slope is 3/4. Here the slope is going to be 2/5. Whether you use the standard shortcut or you solve for y, you'll get slope is 2/5. And from those, we were able to graph it. And so we were able to get points, slope, graph, everything. But we started with equations. So everything, all in our previous discussions, we've done this. Now, this, writing equations, we are going to take this information, maybe even that information, and go backwards. Since this, an equation, we can do anything with. We can find points, we can do anything. We are now going to say, what if we have just one point or just a slope? Can we go backwards and do it? So that's what we're talking about today, is going backwards and being able to find the equation and how this works. So, as a reminder, we have two major forms, slope-intercept and standard form. And let's review first with slope-intercept how we got these equations. So, if you had an equation y equals 5/3 x plus 4, the slope is, oh look at that, the slope is 5/3. It's just the number right in front of there. That's why they call it slope-intercept. If we had y equals 7/8 x minus 2, the slope is 7/8. Had y equals -8 x plus pi over the square root of 17, the slope is -8/9. And of course, we could also grab a point out of all of these. The easiest point here, that intercept, is 0, 4, right here. The point here is 0, -2, and the point here is 0 and, ooh, yuck, pi over the square root of 17. There we go. So now we can work on going backwards. Now, you'll notice that the majority of these equations, this y equals mx portion, is what told us what the slope was. This over here was on a specific point, but, well, look at this. If you have slope equals 7/3, you can write most of the equation. You can say, hey, y equals 7/3 x plus 9. Hey, that has a slope of 7/3. Or y equals 7/3 x minus 4. That one does. Y equals 7/3 x plus 94. All of these have slope 7/3. And so now it comes down to, you could write tons of them. So the first step in writing an equation of line, we have a billion of these here, is to put in the slope. So we're going to write that up here. Step number 1, put in the slope. That gives you the majority of the equation. It gives you this much of the equation right here. This might be something completely weird, but at least we have this much. So put in the slope first. Now, can you tell which one of these lines goes through the point 0, -4? If we specify a point and we go backwards like that, you're like, oh, that one doesn't work. That one does. Look, there's our line right there. Let's try another one really quick. What if I said the slope is 8/17? Think of all the different equations you could write with 8/17. Y equals 8/17 x plus 11, y equals 8/17 x minus 39, y equals 8/17 x plus 238. And people will say, where are you getting these numbers? 11, 39, 238. Actually, I just pulled them out of the air randomly. You could put any number here you wanted if it just said, what's the slope of 8/17? we have the majority of the equation. So when it gives you a very specific point that it has to go through, you have to tell which line actually works. Like say it gave you the point 17, 19. Which one of these points actually has that line? And you may think, oh, I don't know. How do you get that? Well, let's go way, way back to the very beginning. If I stick this guy in right here and this guy in right here, I can tell if it's on this line based on whether or not that is true. Now, if they give you an intercept like this one, you're like, oh, I know how to identify the intercept. Poof, it's right there. But if they don't give it to you, you have to say, ooh, which one of these does this? Well, let's try it. If I stick it in here, 19 8/17 times x, which is 17, minus 39. Let me see. Cancel those. 8 minus 39, does that equal 19? Nope, that one didn't work. Let's try it up here. 19 equals 8/17 times 17. And we have plus 11. Does that work? Like, yes, it works. You're like, hey, but how did you get that? Well, that is a great question. Let's do one where I give you the slope and the point, and we'll show you how to get this number without just guessing and checking. So let's try one where we have given the slope is 3/4 and it goes through the point 5, 2. Now we know we can just put in the slope and we have y equals 3/4 x, but we don't know what this b is over here. So our goal is to find out what the intercept is. We weren't given the intercept, it was 5, 2, but we do know that whatever that number is, if we stick the 5 right there and the 2 right there, that this b has to work. So we use that kind of as a clue. That'll tell us what b has to work. So let's try it. This is 2 equals 3/4 5 plus b. So we write this out. 2 equals 3/4 times 5 is 15/4. Uh-oh, we've got some fractions, but that's all right. Subtract 15/4 from both sides, and we get b equals, this is 8/4 minus 15/4, negative 7/4. This is the number that has to work. So we can actually write our equation. We know what b is now. Y equals 3/4 x minus 7/4, because that's the b. And that's our equation. And you can check it out. Does it have the right slope, 3/4? Yes, indeed. If I stick 5 there and 2 there, based on this solving of the equation, we know that that'll come out to work. We now have the equation. We went completely backwards. We started with slope and a point and went backwards and now found the equation, which we could find everything else. Let's write this down, what we did. We first put in the slope, got that part. Then we put in the point. So this tells you immediately you have to have two things in order to write an equation of a line. You need a slope and you need a point. With a slope, if you just have slope, you're going to get a billion different equations. If you have one particular point, then you're like, aha, we can find out that exact line. Let's do one more example. We want the equation of the line that has, say, slope negative 5/3 and goes through the point 2, 4. So we first put in the slope. That's going to be y equals negative 5/3 x plus this. We don't know. We don't know what b is yet, but now we put in the point. So we stick that in. Stick 2 in for x, so that's negative 5/3 times 2 plus b equals 4 goes in for y. And really, there are going to be infinitely many x's and y's that go in there, but we're just putting this one in there to help us to find b. So we get 4 equals negative 10/3 plus b, add 10/3 over, and we get that b equals, this is 12/3 plus 10/3, 22/3. So then, the last step, we write that equation out. We know it's going to be y equals negative 5/3 x, but now we know the b. 22/3. There we go. Oh, we better write that down as step number 3 and keep that in mind. We write the whole equation out. Our answer isn't b. Even though that helps us when we get to b, that's not the answer. Our goal was to write the equation. Write the equation. Good deal. Okay, now let's try doing the same thing over here with the standard form. Remember, equations like this look like 2x plus 5y equals 13. The slope here was negative 2/5. That's the shortcut. If we had 3x plus 7y equals 15, the slope was the opposite of 3 over 7. If we had 5x minus 9y equals 38, then the slope was positive 5/9 because you did a negative 5 over this negative 9. Remember, you always have this negative going on, so it switches the sign from what was in here. So that's the question. Can we start going backwards on these? So let's try it. If we had a slope of, let's say, 7/3, could we transfer that back and see what equation that came from? Well, yeah. It would have been a 7x minus a 3y. Or you could have done negative 7x plus 3y if you wanted to. It's kind of common practice to have this leading number over here, have it be positive in standard form. So I will always do it with this one, 7x minus 3y. I change the sign of the second one. And let me see, there are lots of them. 7x minus 3y equals 85, or 7x minus 3y equals 94, or 7x minus 3y equals 18. 7x minus 3y equals 37. So you have a whole bunch of them, but you'll notice that the slope is really tied to the majority of the equation, not this in number. So if you just have the slope, you have this much of the equation. So how do we find this? Well, you can take a guess if you're only given slope. You can put in any number you want there. But if they give you a particular point, say 3, 1, again, just like the standard slope-intercept form, the standard form, you put this in. So here you can see we put the slope in and we get a whole bunch of different options. Now we got to find out which one actually goes through the point 3, 1. So let's try it. If we put 3 in for x and 1 in for y, then we get, let's try this, 7 times 3 minus 3 times 1. Does that equal 85? 7 times 3 is 21 minus 3. That's 18 equals 85. Nope, it's not this one. Hey, but look at what just happened. We know that if we stick this in, we're going to get 18 on the left-hand side. Oh, look at that baby right there. And you may be thinking, hey, we got lucky. Try that one again. Well, yes, exactly, but we're going to do it. Let's try it like this. Let's do a negative 4/11, and now we're going to go through the point 5, negative 2. So here's how it works. The shortcut for standard form was this is the opposite, so there's the negative, so that number goes in front of x, 4x plus 11y equals, so remember that's the tough thing about standard form is that opposite one, equals some c over here. We're not sure what that number is, but watch how nice it is to plug this point in. If we stick a 5 right here and a negative 2 right there, can we tell what number has to go over there? Sure we can. This is 20 minus 22. So this is negative 2. We now write the entire equation. 4x plus 11y equals negative 2 is the line. You'll notice what's the slope? Negative 4/11, and that point works. So we now have the equation and can do everything else in the world. Okay, so here we have a question. Write the equation of the line that has slope 3/5 and goes through the point 5, negative 2. We have the same problem. We're going to do one with slope-intercept and one with standard. And really, you could pick which one you wanted to do. We're not going to require you to do one or the other, but it's nice to be able to understand and see the advantages of both of these. So the first one, step number 1 is to put in the slope. Slope-intercept, that looks like this. Y equals 3/5 x. Good. We just put in the slope, but we don't know what b is yet. So now, step number 2, put in the point. So we actually put 5 in for x, 3/5 times 5, and -2 in for y. Good, and let's solve that guy. -2 equals 3/5 times 5, that's 3 plus b. Oh, no fractions, that's nice. Subtract 3 from both sides and we get b equals a -5. Good, now we know what b is. We put the point in, we now write the equation. Y equals 3/5 x, and b is a -5. There's our answer. This is the equation of the line. That's why we had to rewrite it. That this is not our answer. There we have it, 3/5 x -5. Let's try the same problem over here. We have a slope of 3/5. Now in standard form, the shortcut was that 3 is in front of the x, and the opposite of this number is in front of the y. So 3x minus 5y, that gives us that one. Now we put in the point. So we just put in the slope. So we now put in the point, put a 5 there, and a -2 there. So we get 3 times 5 is 15. Minus 5 times a -2 is a plus 10. And we get 25 there. So this has to equal a 25. So let's write out the equation. 3x minus 5y equals 25. And we can double check and say, oh, does this have slope 3/5? It indeed does. And does it go through the point 5, -2? Yes, it works. Now you may ask a question, you're like, okay, well what about this? Are those two the same line then? They could both have the same slope and the point? Yes, they indeed are. I'm going to, just for fun, we're going to do this. 3x minus 5y equals 25. And I'm going to solve this guy for y. And watch what happens. If I subtract 3x, I get minus 5y equals -3x plus 25. Divide by -5 everywhere. And I get y equals 3/5 x minus 5. Wow, isn't that stinking awesome? There you get the exact same thing. And you could do the same thing over here. Times everything by 5 and move the x over to the other side, and you would have this equation. They can go back and forth and back and forth. It's like you're playing with these lines like a child plays with a toy. You're able to do this. Here, you're writing equations of lines, and you can pick to do either one, whichever one suits your fancy best. Okay, here are some problems for you to try. Put these in your video notebook. There are 2 problems here. This one's the same as this one. This one's the same as this one. You are welcome to do it in SlopeIntercept or standard form. I will work them both out, assuming that some students will do some of each. So just go ahead and do one. Put it in your video notebook. Press pause, and when you have completed it, turn the video back on, and we'll see how you did. Good, welcome back. I hope you're able to do these. Let's do it. First, put in the slope. So SlopeIntercept, y equals 5/8 x plus b. We don't know what the b is, so we now put in the point, 2, -4, and solve for b. This is -4 equals 10/8 plus b. Subtract 10/8 from both sides, which is the same as 5/4. So subtract that over there, and we get b to equal -42/8 or 21/4. Good. So we now, step 3, write the equation. Y equals, we now have the slope of 5/8 x minus 21/4. And there we have it. Over here, we'll do the same thing, but we'll do it with standard form. This is 5x minus 8y. There's the shortcut. Then stick a 2 in here and a -4 in there, and we get 10 plus 32 is 42. And write the equation like that. Good. The next one's down here on the bottom. Slope is a -3/5, so that's y equals a -3/5 x. And if we put in the point 0, oh, this is the y-intercept. Somebody was nice to us. SlopeIntercept, we're done. Now if you stuck in 0 there, you would have had y equal, or 9 equals 0 plus b. And you're like, oh, hey, b is 9, and you could stick it in. Over here, this is 3x plus 5y. That's the shortcut. Remember, this is a minus, so that's a plus. Equals, and then we stick in the point 0 there, and a 9 there. And we have 0 plus 45. That equals 45. And so there's our equation there. Good. I hope you did all right. For the last type of problem, we are looking at what if they don't give you the slope, but they happen to give you 2 points. You're like, find an equation that goes through these 2 points. Well, shoot, how do we do that? How do we do that? Well, we've got to have the slope. Can we get slope from this? Certainly we can. We do slope equals y minus y over x minus x, and we get 3 over negative 1. That's going to be a negative 3. So then you write, put it in. Y equals negative 3x. We just put in the slope. And now we've got to put in that b. We've got to put in the points to see what it is. But you're like, uh-oh, which point do we use? Well, let's give it a try and see what happens when we stick in, say, 2, 7. Y 7 equals negative 3 times 2 plus b. What do we get here? 7 equals negative 6 plus b. Add the 6 over and we get b equals 13. So if we stuck in this point, we get the line y equals negative 3x plus 13. Now let's stick in the other point at this one. So y equals negative 3x plus b. We're going to stick in 3, 4. Negative 3 times 3 plus the b. Let's see what we get. 4 equals negative 9 plus b. b equals 13. So we would get y equals negative 3x plus 13. And you may be thinking, oh my word, you ended up with the exact same thing. Well, of course we did. If we're drawing the line that goes through these 2 points, on a graph it would look like this. 2, 7 and 3, 4 looks like this. There's our line. Both of them had better work in the equation that we end up with. They had both better fit in there if they're both on that line. So yes, it doesn't matter which one you use to stick in, and you could have picked any other points on that line to stick in, and you would end up with this exact same equation. Now let's do the same thing in standard form over here. The slope is 7 minus 4 over 2 minus 3. Just like we've done slope in the past, and we get 3 over a negative 1, we still get the negative 3. So that's the exact same. Now when we put the slope in standard form, this becomes, this 3 over 1 is going to be a 3x plus a 1y equals, and now we stick in these points. Stick a 2 there and a 7 there, and we get 3 times 2 is 7. 3 times 2 is 6, plus 7 is 13. So we get this one. Now if we try it with the other guy, 3x plus y equals, and we stick in 3 here and 4 here, we get 13. Now you only have to do one of them, but I put them both in to show you that you get the exact same thing, and it doesn't matter which one of these you pick. Okay, there's one last thing that we need to go over that's going to kind of be tricky. There were some problems that weren't really in y equals mx plus b. I mean, we had x's that left. You remember if it was like y equals 7, this meant that it was horizontal up here at 7, like that. Or if it was like x equals 3, it would be over there. So I'm going to put it down here, not really slope-intercept or standard, but remember that all of these guys were horizontal or had a slope of 0. Now you could put 0 in for x and see what happens and use y-intercept, but these are kind of, or consider this standard, I don't know. But I like to think of them as just going straight to the top vertical. All of these points were 3, 7, 3, 5, something like that. And all these points were like 5, 7, 0, 7, stuff like that. So all the horizontal ones were y equals, and all the vertical ones were x equals, and this was where the slope was undefined. So if you have this and it says, write the equation of the line that is horizontal, or y slope of 0, and goes through the point 2, 9. Now if you look at it, you can kind of see what's going on here. It goes through the point 2, 9 and is straight across like that. you can just skip right to the answer and say, oh, this is a y equals, and how high up are we if we went through the point 29? Bing, 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 bing. That is our y value. All the y values are at 9 if I'm horizontal, so just y equals 9, and you're done. Same thing occurs if it was write the equation of the line that is vertical or has an undefined slope and goes through the point 2, 9. Well, here we're going through the point 2, 9, but notice we are now like this, vertical. Well, all of those look like x equal. So you're like, x equals what? Bing, 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 bing. X is always over at 2, and you're done with the equation there. That should help you complete all of the problems.